Hello esteemed viewers, welcome to our tutorial for today. In our maths tutorial for today, we are going to look at the derivation of trigonometric ratios for angles. Now, this class is going to be an interesting one because at the end of this class, you will know how to derive complex trigonometry ratios using just this right angle triangle that is given to us. Now, from this part, we want to let this triangle be triangle ABC, and it is right angled with at this point. It is right angled at B with AB equal to X and BC equal to Y and then AC equal to R, and the angle CAB is equal to theta. Now from these angles, we are going to derive some trigonometry ratio. But before we do that, I want you to take note of this trig ratio. Take note of this. SOHCAHTOA. Now what does SOHCAHTOA mean? SOHCAHTOA means sine. We have sine opposite over hypotenuse. We have cos, which is adjacent over hypotenuse, and we have tan, which is opposite over adjacent. We are going to use that to derive apply that to this right angle triangle, and we're going to derive a lot of trigonometric ratio. If you are ready, then we can start. Now let's look at the first trigonometric ratio we want to derive today. We want to derive sine theta. We want to look at what sine theta will be. Sine theta is going to be, this is the angle we are talking about. The opposite side is going to be this side, and the hypotenuse side is going to be this angle. So it's going to be opposite over hypotenuse. So we're going to have y over r. That's the value for that. Now we're going to look at cos of theta. Now cos of that angle theta will give us what? Cos is adjacent over hypotenuse. So this will give us the adjacent, while this remains the adjacent. The hypotenuse is r. So cos theta is going to give us x divided by r. Now let's look at tan theta. Now tan theta is going to give us tan what? Tan theta is opposite over adjacent. Now the opposite of this angle is y and the adjacent is x. So tan theta is going to give us y divided by s. Beautiful. Now having derived that, now we can now go ahead to feed ourselves with the next step of trig angles we want to derive. Now, from this above trigonometry ratio, we can derive some other trigonometric property. Now, the inverse of sine, what is the inverse of sine? The inverse of sine is cosec, cosecant, which is equal to the inverse of sine. And that will give us 1 divided by the value of sine, which is 1 over r. And if we do this properly, we're going to have r divided by y, which is the inverse of this value, and that will give us what? That will be equal to 1 divided by sine what? Sine theta. Remember, sine theta is 1 divided by r. So cosec theta is the inverse of sine theta, and this remains what cosec theta is. We're now going to look at sec theta. Now, what is sec theta? Sec theta is just the inverse of cosec theta, and that is the inverse of cos, and that will give us 1 divided by our cos is x divided by r. So this value will give us r divided by x, and that very aspect will be equal to 1 divided by cos what? Cos theta. So the sec theta is equal to 1 over cos theta, and that is the inverse of theta. The final one we're going to look at cot theta. And what do we have in cot theta? Cot theta is another unique trig ratio. Cot theta is the inverse of tan theta, and that is tan theta is y divided by s, and this will give us x divided by y if we divide that, and this will be equal to 1 divided by tan theta. Now let's take note of this trig function. Now, having seen this trig function, we can now play around with the other part of trig function we'll have. The next set of trig function we'll also have the tan theta. Someone will always tell you that tan theta can still be equal to, it gives us y divided by x. But then it can still be equal to sine theta over cos theta. Now, to have this y divided by x, we'll see that we'll have y divided by r divided by x divided by r. Now, if we divide this value, you're going to see you will have y divided by x. So that means it really shows us that tan theta can be equal to sine of theta divided by cos of what? Theta, because this is cos of theta. Now let's bring these two values here. When we have y divided by r multiplied by r divided by x, you find out that r will cancel r, and then we'll have y divided by x, which is exactly this. So that shows us that tan theta can be equal to sine theta divided by cos theta. Another unique one we want to look at is cot of theta. Now, when we have cot of theta can give us the value x divided by y, and that we have seen as the inverse of what? The inverse of tan theta. We'll go ahead to simplify this. We'll see that this will give us x divided by r divided by y divided by r. So that means cot theta can also be equal to cos theta divided by sine what? Sine theta. That's another good trigonometric property. Now, having gotten all these property, we want to take our time now to analyze this triangle and then come out now properly to derive our trigonometry ratio. Now, the trig ratio we want to derive are the ones that are very, very important. Now, let's consider that triangle we drew. From that triangle, we'll have, remember, from that triangle, we'll have our C, we'll have our B, we'll have our angle A, and then this is the right angle. While this remains theta, this is R, while this is Y, and this is what? X. Now, for us to derive our trig functions properly, we are going to first of all look at the Pythagoras theorem of this triangle. Now, if we take the Pythagoras theorem of this triangle, according to Pythagoras theorem, the hypotenuse, the square of the hypotenuse will always be equal to the sum of the other two sides, which is r square is equal to y square plus x square. So that means the sum of the other two sides can be equal to the hypotenuse. So we'll have our y square plus x square being equal to r square. Now, to derive the first trig value, we want to divide through by r. If we divide this part by r square, divide here by r square, and divide here by r square, we are going to have this trig value gives us y divided by r all square plus this will give us x divided by r all square, and then this will be equal to 1. Now let's get back to what we initially have. What is y divided by r? If we have y divided by r is what? That's sine theta. Good. And what is x divided by r? X divided by r is cos theta. So what will it invariably gives us? It will invariably give us sine of square theta plus cos of square theta equal to 1. That's the first trigonometry ratio we'll derive. So the first trigonometry ratio we'll derive is sine square theta plus cos square theta equal to 1. Now let's go ahead to also look at that Pythagoras theorem once more. Remember the Pythagoras theorem. From the Pythagoras theorem, we said y square plus x square is equal to r square. So this time around, we'll look at it as s square plus y square equal to r square. So what do we do from here? The next thing we'll do from here is to divide through by x square. If we divide through by x square, we are going to have, let us divide through by x square. If we divide through by x square, we are going to have this divided by x square, this part divided by x square, and this part divided by x square. So this will clear to give us 1 plus we'll have y divided by x all square equal to r divided by x all square. Now let's go back to our trig function. Where do we have y divided by x? Y divided by x, we'll find it as what? As tan theta. Then the next one, where do we have r divided by x? R divided by x, r divided by x is sec theta. So we're going to look at that and put that in. If we put that in, we are going to have the trig function to be 1 plus tan square theta equal to sec square theta. This is another trigonometric function that we want to have at the back of our mind and we want to always use whenever we are solving questions on trigonometry. Now let's go ahead to the final trig function. To get the final trig function, we'll still cast our mind back to our Pythagoras theorem. Now in that Pythagoras theorem, remember we said y square plus x square is equal to r square. This time around, we are going to divide through by y square. So we'll have y square divided by y square divided by y square. This part will give us 1 plus this other part will give us x divided by y all squared, and this other part will give us r divided by y all squared. Now let's go back to our trig functions. Where do we have x divided by y? Where do we have x divided by y? Where do we have x divided by y? This is it. We have it under this. Cot theta is x divided by y. So the next one is r divided by r. Where do we have r divided by y? R divided by y. This is it over here. So cosec theta is r divided by 1. So we're going to apply that here and then find the final trig function. The final trig ratio will now give us 1 plus this part will now give us cot square theta equal to cosecant square theta. So that means this is another trigonometry function. So from here, we have derived using this right angle triangle, we have derived three important trigonometry functions that you're going to make good use of as you progress in learning trigonometry. Now let's see how we can apply this in solving questions related to trigonometry. Now assume you are given a question, and in that question you are told that if cos theta is equal to 1 divided by 2, and they gave you the condition that your 0 degree is less than or equal to theta, and is less than or equal to 90 degrees. So that means the range of the angle must be between 0 and 90 degrees. If you are asked to find sine square theta, that's the A part, and B, you are asked to look for cot square theta, and C, you are asked to look for tan theta. What are you going to do? Now we're going to look for how we'll solve this question. Remember the question, we are asked to find sine square theta, and we are asked to find cot square theta and tan square theta. Now the first one we're going to find, we're going to look for the value of sine square theta. Now recall that formula, that trig ratio we derived, that cos square theta plus sine square theta is equal to 1. And we've already been given that our cos theta is 1 over 2. So we'll have our 1 divided by 2 here squared plus sine square theta equal to 1. So our sine square theta here will be equal to this whole value will move over to this point. So we'll have 1 plus 1 divided by what? 4, because 1 square is 1 and 2 square is equal to 4. So if we simplify that, we'll have sine square theta to be equal to, if you simplify that, we are going to have that to be equal to 3 divided by 4. Having gotten that 3 divided by 4, that is what we are looking for. We are looking for sine square theta. With that value, we have gotten what sine square theta is. That is what we are asked to look for. The next value we are asked to look for, cot square theta. To find cot square theta, all we need to do is to apply the second formula. You see the importance of that formula. We'll have our 1 plus cot square theta. We said it's equal to cosec square theta. So having gotten that, you know that cosec square theta, cosec is the inverse of sine. So we'll have 1 plus cot square theta to be equal to 1 divided by sine square theta. So having gotten the value for sine square theta, we won't have troubles doing this. We'll have 1 plus cot square theta equal to 1 divided by 3 divided by 4. So that will give us 1 plus, this will give us 1 plus cot square theta to be equal to 4 divided by 3. So if this comes over here, we'll have cot square theta to be equal to 4 divided by 3 minus 1. We'll simplify that. We are going to have our cot theta, which is what we are looking for, to be equal to 4 minus 3. That will give us 1 divided by what? 3. So cot square theta is equal to 1 over 3. That's what we are asked to look for. Third one, we are asked to look for tan theta. Now, tan theta is equal to, tan theta will give us, we know that basically that tan theta is equal to sine theta divided by cos what? Cos theta. And what do we have as our sine theta? Recall that we have our sine theta to be our sine square theta to be equal to 3 divided by 4. So if sine square theta is equal to 3 divided by 4, if we square both sides, we are going to have our sine theta to be equal to square root of 3 divided by 2. So that will be the value. And from our initial expression, we have our cos theta to be equal to 1 divided by 2. So our tan theta now will be equal to, square root of 3 divided by 2, all divided by 1 divided by 2, and that will give us root 3 divided by 2 multiplied by 2 divided by 1. So 2 will clear 2. So that means our tan theta will be equal to square root of 3. So this is how you apply those trigonometric problems, those trigonometric equations in solving problems like this. Bravo! In today's class, I've been able to show you how to derive trigonometric functions and how to also use such functions in solving trigonometry equation. Now, I want you to try these questions. Try these questions, and if you get your solutions, don't forget to drop your solutions in the comment section. The solution to this video, to these questions, will be produced as videos in our subsequent videos. Don't forget to try it, and you'll be glad you truly did. In this question, you are asked to find sine theta. B, you are asked to look for tan theta. And C, you are asked to look for cos theta. So try these questions, and don't forget to click the bell icon to be notified when the solution tutorial of this question will be uploaded. Don't forget to subscribe to this channel so that we can always get you simplified mathematics solutions that can truly make mathematics fun for you. Thanks so much for watching, and I look forward to seeing you watch our subsequent videos.